These are the one-step molar conversion notes. You will want to have a periodic table handy and a calculator. Yesterday, or in the previous video, we talked about what is a mole. And we know that 1 mole is equal to a certain number of particles, and also a mole is equal to a certain number of grams for a specific compound. So with these one-step conversions, we're going to go between moles and grams using that relationship of 1 mole equals the molar mass. And then we're also going to go between moles and particles because we know that 1 mole equals 6.022 times 10 to the 23rd particles of any substance. And we're going to use a process called dimensional analysis in order to calculate those conversions, or kind of the factor label method if you've heard of that. We're going to start off with that gram-mole relationship. So again, remembering that 1 mole is our molar mass in grams. We find that molar mass using our periodic table. And we're going to use rounded values, so rounding to the nearest whole. If we're doing a gram to mole conversion, we're going to be given some number. And so there's a number sign there because we are given this value. In order to go from grams to moles, because 1 mole is equal to molar mass in grams, if we want to cancel grams, and grams are in the top here, we're going to put grams in the bottom, and that's going to allow those to cancel. Whatever we want to end up with, if we're going from grams to moles, we want moles, that's going to go in the top of our conversion factor. So in a grams to mole conversion, we're going to use this conversion factor where moles are on the top. If we're going the other way, if we're starting with a given value of moles and we want to find grams, because we want to cancel this mole, we put moles of that conversion factor in the bottom. We're going to put molar mass on the top because we want to end up with grams, and our conversion factor is going to be written this way. So our goal is to cancel what we have and change that unit to something else. So here's an example. We have 9.84 grams of barium hydroxide is how many moles? And so with this one, we do need to know, if we're going with grams, we need to know the molar mass. So we need to write that chemical formula. Barium hydroxide, this is ionic. So I'm going to need to use charges in order to write that compound. And so barium has a charge. If I look at my periodic table, barium has a charge of +2. Hydroxide is one of our polyatomics. That's OH with a -1 charge. To make that a neutral compound, we drop our signs. So I'm going to just take the 2 and the 1, and I'm going to switch them to the other element. So I'm going to need 1 barium and 2 hydroxides. So my chemical formula is BaOH2. And once I know that chemical formula, I can find the molar mass. Barium, I have 1 barium, and going to my periodic table, barium has a mass of 137.3. So I'm going to just round that to 137. Now oxygen, you can do this 2 ways. You can either figure out what is the mass of our OH group and then multiply it by 2. I normally, though, will distribute and say, okay, I have oxygens and hydrogens. I have 1 oxygen, and then 2 times 1, 2 of that group, I'm going to have 2 oxygens total. And so 2 times, going to my periodic table, I get that oxygen has a mass of 16. So that's 32. And then same thing with hydrogen. I have 1 hydrogen, but I have 2 in that OH group, but I have 2 OH groups. So that means I have 2 hydrogens total. And each hydrogen has a mass of 1.008, but we round to 1. And so that's going to be 2. And then I'm going to add all of those up to get my total molar mass. So I get a molar mass of 171 grams per mole for barium hydroxide. So if I now want to convert from grams to moles, I have to go back to my starting value. And I always put my starting value first. And that's what I'm changing the units of. I'm not changing the value of it. I'm just changing what we're measuring it in. So we have 9.84 grams of our barium hydroxide, and we are converting that to moles. So I'm going to need to write my conversion factor here. Whenever I do that, because I'm going to be working with multiplying fractions, I like to put my first starting value over 1, just so then I have a fraction. And as I look back, because I'm going from grams to moles, I'm going to write my conversion factor this way, where 1 mole is on the top and the molar mass is on the bottom. So we're going to have our molar mass on the bottom, so 171 grams of barium hydroxide on the bottom, and then 1 is equal to 1 mole of barium hydroxide on the top. And we can check our work by looking at our units. Grams of barium hydroxide are on the top and on the bottom, meaning that they are going to cancel each other out. So we're going to be left with those units of moles, which is what we want. And now we're able to go and do the math. So now we're going to take our values and I'm going to multiply everything on the top. 9.84 times 1 is 9.84 over 1 times 171, 171. And I'm going to divide the top number by the bottom number. 9.84 divided by 171, and I get 0.0575 as my answer, and I'm going to say moles of barium hydroxide. So that's my answer. I'm not sure what rounding rules will be with that, but that's going to be fine for now. We need to make sure also to include a unit, so moles on our answer. If instead we're going between particles and moles, 1 mole of anything is equal to that 6.022 times 10 to the 23rd particles. Depending on what we're starting with, if we're starting with a given number of particles, then how we're going to set up our conversion factor is with that 6.022 particles on the bottom and 1 mole on the top. Again, that's so that we get those particles to cancel, leaving us with a unit of moles. If we're doing a mole to particle conversion, we're going to start with our given number of moles, and we're going to put moles in the denominator of our conversion factor, particles in the numerator, so that we can end up with particles in our answer. So it's the same idea for both, it's just that our conversion factor here is relating moles and particles, whereas before it was moles and grams. All right, so if we have 6.547 times 10 to the 24th particles of NaOH is how many moles? With particles, we don't have to find the molar mass, so I'm not going to need to find it here. We've got 6.547 times 10 to the 24th particles of NaOH is my starting value. So I have to write that down so that I have a number to then change the units of. And when I'm looking at what's my conversion factor gonna look like, our conversion factor is 1 mole equals 6.022 times 10 to the 23rd particles. I'm gonna put what I wanna get rid of on the bottom. So I'm starting with particles, so I'm gonna put that 6.022 times 10 to the 23rd particles on the bottom. And then I'm going to put that 1 mole on the top. So 1 mole of NaOH on the top. And we do that so that our particles of NaOH that are on the top and our particles of NaOH that are on the bottom, those units can cancel. And so then I can go ahead and do my math. I'm going to do 6.547 times 10 to the 24th times 1, which is 6.547 times 10 to the 24th, and then I'm going to divide it by everything in the denominator multiplied together. 1 times 6.022 times 10 to the 23rd, which is just 6.022 times 10 to the 23rd. And then I'm going to divide those two. And you should be using scientific notation. If you need help with scientific notation, I will put some resources in the Schoology folder for you, or see a teacher for help on using a calculator. So when I divide those, I should get 10.87, and I'm rounding just to 2 decimal places here. It's 10.87, and I need to make sure I put units on my answer. So I'm going to go back and I can see that my units were moles of NaOH, and then that is my final answer. So 10.87 moles of NaOH is equivalent to 6.547 times 10 to the 24th particles. A little chart that we're going to use, and we're going to kind of add to this, is this conversion chart here, and it kind of shows us the conversion factor and how we can go back and forth. So that conversion factor is written here for us. We're going to decide what goes on the top and what goes on the bottom based on what we want to cancel. And this is equivalent to that particles, or molecules. I know we've been calling them particles. Sometimes other places will call them molecules. And so between particles and moles, that's our conversion factor. Between moles and grams or mass, that's our conversion factor. And so we can kind of use that to help us determine where we're going to go. All right, so here's another example. How many grams, so our unknown is grams, are in 3.4 moles of sodium fluoride? So with this one, we're going to be doing a moles to grams conversion. If I look back at my chart, doing a mole to gram conversion here, I'm going to have 1 mole is equal to molar mass, so I am going to have to find the molar mass for this compound. So find the chemical formula first. If we have sodium fluoride, sodium has a +1 charge. Fluorine has a -1 charge. So when I do my drop and switch, I'm going to need 1 sodium and 1 fluorine, NaF. And so I can find what is the molar mass. Sodium, I have 1 sodium. Each sodium has a mass of 22.99, which would round to 23. Fluorine, I have 1, and it has a mass of 19. And we can add those up, so we get 42 grams per mole is the molar mass of fluorine. So we're going to need to use that in our conversion. So setting up, now we calculated the molar mass, then use the molar mass to convert from moles to grams. So I'm given 3.4 moles. That's going to go in the top of my conversion factor. So this is moles of NaF. Now my one-step conversion, I'm going to put my conversion factor here. And when I'm looking at this, 1 moles to mass, whatever one I'm starting with is what's going to go in the bottom. And so whether it's 1 mole or the molar mass. So I'm starting with moles, meaning I'm going to put moles in the denominator so that those cancel. And 1 mole is equal to the molar mass. We know we can look back to the chart and see that conversion factor. That molar mass we found was that 42 grams of NaF in 1 mole. And that's our work for showing our setup. Our moles of NaF are going to cancel, leaving me with grams, so I can go ahead and do that math. I'm going to multiply everything in my numerator. 3.4 times 42. I get 142.8. and then I'm going to divide by and multiply by everything in my denominator. 1 times 1 is 1. So 142.8 divided by 1 is 142.8. And then we need to go and grab our units. Our units were grams of NaF, sodium fluoride. All right, one more practice together. Feel free to pause if you think you can do this one on your own. How many particles, so my unknown is particles, are in 4.5 moles, this is my given value, of calcium hydroxide? Use Avogadro's number to convert from moles to particles. So if we look back at that conversion chart, going between particles and moles, that conversion factor doesn't have any value we need to find. It's always that 6.022 times 10 to the 23rd. So I don't need to find my molar mass on this one. I can just go ahead and set this up, starting with my given value. So my given value is 4.5 moles of calcium hydroxide over 1. And then setting this up, really, what's the relationship between particles and moles? Moles are going to go on the bottom. And we know that 1 mole is, if I go back, 6.022 times 10 to the 23rd particles. I didn't write my calcium hydroxide on the back here. That would be CaOH2, or at the end. We'll put that into our answer. It's going to be important that we keep writing that later on. But now I can go ahead and do my math because my moles cancel. So going and doing my math, I'm going to multiply all the numbers in my numerator together. 4.5 times 6.022 times 10 to the 23rd. I get 2.7099 times 10 to the 24th over, and I'm going to divide by everything in the bottom, multiply together. In this case, it's 1. And so our answer is going to be 2.7099 times 10 to the 24th divided by 1. And let's round to 2 decimal places. So 2.71. This 9 is going to round that 0 to a 1. But then we still include our times 10 to the 24th. Particles of calcium hydroxide. Save this chart if this is helpful for you. We're going to see something similar to it next unit as well, but it can kind of help stay organized and help you use those, stay organized and know what conversion factor you're using. There are some individual practice here with some answers provided as well. There is a one-step conversion worksheet with answers provided and a check-in on Schoology for you to complete as well.